Module 4. Capturing sensor data over USB. In this module, we will use the command line interface to capture data over USB. We will learn to use the software tagging feature to track sensor states. Finally, we will use Python scripts to plot and convert captured data files. Press the reset button. The orange LED should be blinking rapidly. Open a File Explorer window and navigate to the microSD card root directory. We will need our customized JSON device configuration file. Copy the device config file. Navigate to the workshop directory. Open the data log folder. Open Utilities. Open the CLI example folder. Open the bin folder and paste the device config file. Once completed, type CMD in the File Explorer path bar and press Enter. A new command prompt window will open within our selected folder. We are going to initiate another data capture using the 330DHTX accelerometer. You will need to make sure that your STWIN board is on a level surface to begin. Type in the following command, but do not press Enter yet. CLI example-F device config JSON-T60. The -F parameter specifies the target device configuration file to be used for this capture. In this case, it is our modified JSON file. The -T parameter specifies the length of sensor capture time in seconds. We are adding a bit of buffer time to allow for board position changing. You will be capturing sensor data with the STWIN board in 3 different positions for about 10 seconds each. First position is on the level surface. Second position is in the palm of your hand with no motion. Third position is in the palm of your hand with slight motion back and forth. We will also be tagging each 10-second position using the software tagging feature of the data capture. The green LED will illuminate to confirm the start of the capture process. Now press Enter to execute the command and then press Enter again to start the logging process. Press the 0 key to tag the level surface position. After 10 seconds, press the 0 key to stop tagging. Now hold the board in the palm of your hand and remain still. Press the 1 key to tag this position. Once 10 seconds has passed, stop the tagging by pressing the 1 key. Slowly start moving your hand for our third capture block. We will mark this position using tag number 2. We will need at least 10 seconds in this final capture position. Press the 2 key to end the tagging when done. The green LED will turn off once capture is completed, and the orange LED will start blinking again to indicate we are back in ready mode. You can close the command prompt window once the CLI application has exited. You should have a newly created timestamp folder with the data we just captured. The folder should contain your captured accelerometer data and 2 JSON files. Rename this folder to STWIN No Shake. Move the No Shake folder to the workshop folder. Let's look at the acquisition file from our capture. Navigate to the workshop folder. Open the acquisition info file with Notepad++. You can see the specific tags that we turned on and off for each 10-second block of time. This tagging information is helpful if you are looking to subdivide the data capture information by specific sensor states or conditions. You can close Notepad++ when you are done viewing the file. We will now look at using Python scripts to plot our captured sensor data. Navigate back to the data log folder. Open the Utilities folder. Open the Python SDK folder. Once completed, type CMD in the File Explorer path bar. Run the Python script by typing in the following command and then press Enter. Python HS data log plot dot py c colon backslash STWIN workshop backslash STWIN no shake. We only recorded a single sensor during our capture, so you will only see one device listed. Press 0 followed by Enter to plot the accelerometer data. Notice the plot shows varying ranges of motion in addition to relatively stable phases. This is because the STWIN gathered data while you had it on a level surface, transferred it to your hand, and then slowly moved it back and forth in your palm. Close the plot window and then press Q to quit. We will now run the same Python script on the data we captured during shaking. Python HS data log plot dot py c colon backslash STWIN workshop backslash STWIN shake. Press 0 to plot the accelerometer data. The plot now shows the large range shake events that were recorded. You can zoom into this data by using the magnifying glass button in the plot window. Close the plot window and then press Q to quit. We will now convert these data files into a format compatible with the STMicroelectronics application for use in our next training module. Run the Python script by typing in the following command followed by Enter. Python HS data log to unico dot py c colon backslash STWIN workshop backslash STWIN no shake. The Python script exports the converted data files into a new folder called STWIN Workshop Exported. Rename this folder to STWIN No Shake Unico. We will now repeat this process for the shake data. Python HS data log to unico dot py c colon backslash STWIN workshop backslash STWIN shake. Rename the exported folder to STWIN Shake Unico. Finish up by moving both folders to the STWIN Workshop directory. We will use these folders in the next training module. You can now close the File Explorer and Command Prompt windows. In this module, we use the CLI application to capture sensor data over USB and use tagging to mark specific sensor states. Finally, we learned how to plot and convert our captured data using Python scripts. This concludes Module 4.